Hello everyone, welcome to Edupedia World. Today we are going to discuss chemical reactions and equations. The topic is covered under the following heads. First, let us discuss about a balanced chemical equation. What is a balanced chemical equation? A balanced equation has an equal number of atoms of different elements in the reactants and in products. So there are certain rules for balancing a chemical equation. The first rule says that the equation must contain correct formula of reactants and products, and formulae must be written in molecular form and not in the atomic form. We should not alter the formulae of reactants and products. The second rule says that appropriate numbers should be written before formulae of reactants and products. The third rule says the law of conservation of mass must be satisfied. The law of conservation of mass requires that the total mass of all the reactants of a chemical reaction must be equal to the total mass of all the products. These rules will become more clear with the help of some examples. So let us take an example. In this, hydrogen burns in oxygen. Hydrogen burns in oxygen to form water. So we can write the chemical equation as H2 plus O2. It will give H2O, that is water. So let us count the number of hydrogen and oxygen atoms in reactants and products. Number of hydrogen atoms, number of oxygen atoms on reactant side and on product side. So there are 2 hydrogen atom on reactant side and 2 on product side. 2 oxygen atom on reactant side and 1 oxygen atom on the product side. So the number of hydrogen atom is equal on both sides, but the number of oxygen atom is unequal. So we have to multiply 2 oxygen atoms on right hand side. So our equation will become H2 plus O2. It will give twice H2O. Now again counting the number of hydrogen and oxygen atom on both sides, that is on reactant side and on product side. Number of oxygen atom on reactant side and on the product side. 2 hydrogen atom on reactant side, 4 hydrogen atom on product side, 2 oxygen atom on reactant side and 2 oxygen atom on product side. So number of oxygen atom has become equal, but number of hydrogen atoms has become unequal. To have 4 hydrogen atom on left hand side, we have to multiply hydrogen by 2 and write twice H2. So our equation will become twice H2 plus O2. It will give twice H2O. Now by counting the number of hydrogen and oxygen atoms, we can easily say that this equation is a balanced chemical equation. Now let us take some more examples, and after that we will be able to balance an equation in just one step. So let us take another example. Hydrogen is reacting with chlorine and it will produce hydrogen chloride. So we have to balance this chemical equation. Hydrogen H2 plus chlorine, that is Cl2 HCl is formed, that is hydrochloric acid, HCl. First we have to balance the number of hydrogen atom on both the sides. So we will write it like this: H2 plus Cl2. We will multiply on right hand side by 2, so our equation will become twice HCl. So we can see that there are 2 hydrogen atoms on reactant side, and on product side there are 2 hydrogen atoms. Now counting the number of chlorine, 2 chlorine atoms on reactant side and 2 chlorine atoms on the product side. So this is a balanced chemical equation. Now let us take another example. Sodium is reacting with water and it is producing sodium hydroxide and hydrogen. Sodium is reacting with water. This is the word equation, and it will give sodium hydroxide and hydrogen. So we can write the chemical equation like this: sodium, it is reacting with water and it will give NaOH, sodium hydroxide, plus hydrogen, that is H2. First let us balance the number of hydrogen atoms on both the sides. On reactant side, on product side, number of hydrogen atom, there are 2 hydrogen atom on reactant side and 3 hydrogen atom on the product side. This we are doing for balancing hydrogen atoms. So what we can do, we will multiply by 2 on left hand side with H2O. It will give and we will also multiply 2 on right hand side, NaOH plus hydrogen. Now let us count the number of hydrogen atom on both the sides. On reactant side 4 hydrogen atoms are there, and on product side 2 into 1, 2 plus 2, 2 plus 2, 4. So hydrogen atom is balanced. Now let us balance the number of sodium atoms. We have to multiply by 2 on left hand side to sodium atom, twice Na plus twice H2O. It will give twice NaOH plus H2. Now this is a balanced chemical equation. Now let us take another example. In this example, there is a reaction between ethane and oxygen. So what is the chemical formula of ethane? C2H6, and it is reacting with oxygen. It will give H2O plus CO2. So first we will balance the number of carbon atoms. Clearly we can see that there are 2 carbon atoms on left hand side of the equation and only 1 carbon atom on the right hand side of the equation. So we have to multiply by 2 on right hand side of the chemical equation. So our equation will become C2H6 plus O2, it will give H2O plus twice CO2. So the number of carbon atom is balanced. Now we will balance the number of hydrogen atoms. There are 6 hydrogen atom on reactant side and only 2 hydrogen atom on the product side. So we will multiply by 3 on right hand side of the chemical equation. So our equation will become C2H6 plus O2. It will give thrice H2O plus twice CO2. So the number of hydrogen atom is also balanced now. Now we will balance the oxygen atoms. We can see that number of oxygen atom on the products is 7. In order to make the number of oxygen atoms in the reactant as 7, we will write it like this, 7O. So equation will become, we are balancing the number of oxygen atoms and we have to write it like this, 7O oxygen atom. So our equation will become C2H6 plus 7O. It will give thrice H2O plus twice CO2. Since by a rule we know that we have to write the formula of reactants and products in molecular form. So we have to change O into O2. Hence every term of the equation is multiplied by 2. So our equation will become twice C2H6 plus 7O2. It will give 6H2O plus 4CO2. We have multiplied whole equation by 2. So now this is a balanced chemical equation. Now let us take another example of balancing a chemical equation. So in this example, sodium hydroxide solution in water reacts with hydrochloric acid solution in water to produce sodium chloride and water. So sodium hydroxide solution in water reacts with hydrochloric acid solution in water to produce sodium chloride and water. We can write the chemical equation like this. NaCl, that is sodium chloride, is formed. So what are the reactants? Sodium hydroxide reacts with hydrochloric acid. NaOH reacts with hydrochloric acid, that is HCl, and sodium chloride and water is formed. NaCl, sodium chloride plus water, H2O are formed. So we can easily see that this equation is already a balanced chemical equation. Number of sodium oxygen, hydrogen and chlorine atoms are equal on the both sides of the chemical equation. So this is a balanced chemical equation. Now the next question which arises in our mind is that how we can improve, or we can say that how we can make a chemical equation more informative. So a chemical equation can be made more informative in the following ways. Physical states of the reactants and products. There are four physical states for reactants and products of a chemical reaction. They are solid, liquid, aqueous solution and gas. So it can be written in small letters in italic space, enclosed in first brackets and placed immediately after formulae in reactants and products. We can see it like this. Solid state is indicated by the symbol S. Solid state. Small letters in italic space, enclosed in first brackets and placed immediately after formulae in reactants and products. So it can be written like this, small s. Now liquid state, small letter L, and gaseous state, small letter G. Aqueous solution can be written like this, aqueous solution in brackets AQ in small letter. Let us make it more clear with the help of an example. Suppose zinc metal reacts with dilute sulfuric acid to form zinc sulfate solution and hydrogen gas. So equation can be written like this. Zn plus H2SO4, it will give zinc sulfate ZnSO4 plus H2. Here zinc metal is a solid, so we can write zinc in solid state. H2SO4 is an aqueous solution, so we can write H2SO4 aqueous solution. Zinc sulfate is also an aqueous solution, so we can write zinc sulfate like this, zinc sulfate in aqueous form. And hydrogen is a gas, so hydrogen in bracket small g. So we can write this chemical equation in a more informative manner like this. Zinc in solid state reacts with sulfuric acid, aqueous solution of sulfuric acid. It will give zinc sulfate, which is again an aqueous solution, and hydrogen gas. Now, second, heat changes taking place in the reaction. There are two types of reaction on the basis of heat changes involved: exothermic reaction and endothermic reaction. The reactions in which heat is involved are known as exothermic reactions. And how we can indicate an exothermic reaction? By writing plus heat. By writing plus heat or plus heat energy or just energy. on the product side of the equation. So remember, when we are told that a particular reaction is exothermic, we should write plus heat or plus heat energy or just plus energy on the right side of the equation. We can take an example. When natural gas burns in the oxygen of air, it forms CO2 and water vapor. A large amount of heat energy is also produced. So this is an exothermic reaction, and we can write the chemical equation like this: CH4 gas reacts with twice O2 in gaseous form. It will give CO2 gaseous form twice H2O in gaseous form plus heat energy, because it is an exothermic reaction. Examples of exothermic reactions are all combustion reaction, combustion of food in our body during respiration. Now let us discuss about endothermic reaction. The reactions in which heat is absorbed are known as endothermic reactions. Let us take an example to make it more clear. When nitrogen and oxygen are heated to a very high temperature, when nitrogen and oxygen are heated to a very high temperature, they combine to form nitrogen monoxide. Combine to form nitrogen monoxide. And a lot of heat is absorbed in this reaction. So we can write it like this: nitrogen in gaseous form reacts with oxygen in gaseous form. A lot of heat is absorbed. This means that this is an endothermic reaction. We have to write plus heat on reactant side. Now it will give nitrogen oxide twice NO in gaseous form. It is an endothermic reaction as heat is absorbed. So we should write plus heat or plus heat energy or plus energy on reactant sides of an equation. Now let us discuss the third point: condition under which the reaction take place. Here, what do we mean by the conditions of a reaction? Actually, conditions of a reactions are pressure, temperature, heat, presence of a catalyst under which the reaction is taking place. Let us make it more clear with the help of an example. When potassium chlorate is heated, when potassium chlorate is heated in the presence of manganese dioxide, catalyst, it decomposes to form potassium chloride and oxygen gas. So we can write the chemical equation like this: twice KClO3 it will give twice KCl plus thrice O2. Potassium chlorate is in solid form, so we have to write small s. Potassium chloride is also in solid form, so we have to write small s on the product side as well, and oxygen is in the gaseous form. So it is clearly mentioned in the chemical reaction that potassium chlorate is heated, so we have to write del sign, which stands for heat. And what is the catalyst? Manganese dioxide is the catalyst, so we will write MnO2. So if we know the condition and temperature and pressure at which the reaction takes place, we can write their values above or below the arrow sign in the equation. Now let us discuss our fourth point. The fourth point says precipitation of a solid during a chemical reaction. It is indicated by placing a downward arrow. We can see downward arrow, or letter S enclosed in first brackets, or letter S immediately after the formula, the precipitate product, without leaving any gap. For example, NaCl aqueous solution reacts with silver nitrate AgNO3. It is also an aqueous solution. It will give AgCl. Precipitate is formed in the form of AgCl. So we will place a downward arrow like this, and sodium nitrate NaNO3 is also formed. NaNO3 in aqueous form. Now let us discuss the next point: evolution of gas during a chemical reaction. Evolution of gas is indicating by placing an upward arrow. We can see it like this. We have to place an arrow pointing upwards like this. Evolution of gas is indicated by this arrow. The letter G enclosed in first brackets immediately after the formula of gaseous product without leaving any gap. So let us take an example of any chemical reaction. Na2CO3 in aqueous solution reacts with hydrochloric acid twice HCl. It is also in aqueous form. It will give sodium chloride twice NaCl in aqueous solution plus H2O liquid, that is water, and CO2 gas is evolved. So we will write CO2 like this. We will place an arrow towards upward direction. So in this way we can improve, or we can make a chemical equation more informative. Thanks for watching Edupedia World Videos.